Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. For most of history, geometry was absolute. It was the world of Euclid, where parallel lines never meet, and the shortest distance between 2 points is always a straight line. This foundational simplicity isn't just a mathematical principle, it is the operating system for your brain. Every single action you take, from catching a ball to walking across a room, relies on the neurological assumption that you inhabit a flat, three-dimensional Euclidean universe. But what happens when you remove that assumption? What happens when your brain is forced to process geometry that is fundamentally wrong? The answer is cognitive collapse, a profound state of disorientation that proves our minds possess a deep, innate terror of the non-Euclidean. Our journey into this cognitive conflict begins in the hippocampus, the region of the brain responsible for memory and spatial navigation. This area houses two specialized populations of neurons: place cells and grid cells. Place cells fire when you are in a specific location, essentially tagging coordinates in your mental map. Grid cells, however, are the cartographers. They fire when you cross specific points in space, creating an interlocking, crystalline network of triangles that tiles the entire environment. Think of them as your brain's internal GPS, laying down a perfect, hexagonal lattice. Critically, this grid is designed for Euclidean space. It calculates distances, angles, and trajectories based on flat, stable reality. This system is so robust that it works even in total darkness. Once the map is built, your brain can navigate using internal consistency alone. Now, let's introduce the forbidden shapes. Imagine a hyperbolic plane, often visualized as a saddle shape. In hyperbolic space, a triangle's interior angles sum to less than 180 degrees, and parallel lines diverge infinitely from each other. Or consider elliptic geometry, where parallel lines meet, and triangles sum to more than 180 degrees, like the surface of a globe. When we expose human subjects to visual environments simulating these non-Euclidean conditions, typically through advanced virtual reality, the neurological system hits a wall. The sensory input, the way objects shrink, the unexpected convergence of lines, the failure of light to behave normally, contradicts the Euclidean expectations hardwired into the grid cells. The input doesn't just fail to make sense, it breaks the mathematical structure of the grid itself. Researchers have found that when people navigate these spaces, they don't just feel lost. They experience intense anxiety, motion sickness, and profound mental fatigue, sometimes even reporting a sense of unreality or existential dread. This isn't merely a psychological response to confusion, it's a physical sign of neurological malfunction. The grid cells, unable to lay down their precise hexagonal tiles in a continuously curving, self-contradictory space, start to fire chaotically. The brain's internal compass spins wildly, unable to synchronize the incoming visual data with its foundational spatial map. This loss of synchronization is the essence of cognitive collapse. It's the brain screaming, "This place is impossible." The most fascinating aspect is that, evolutionarily, we have never needed to cope with this. Earth is locally Euclidean, and our survival relied on accurate navigation under those rules. Therefore, our cognitive architecture views non-Euclidean geometry not as a novelty, but as an error signal, a profound glitch in the matrix. Even professional mathematicians, who understand the concepts abstractly, report difficulty visualizing or mentally inhabiting these spaces. This research has critical implications far beyond abstract math. As we rely more on advanced VR and augmented reality, designers must be cautious about inadvertently triggering these hardwired spatial anxieties. Furthermore, for astronauts engaging in deep space exploration, where familiar terrestrial visual cues vanish and perception of distance becomes abstract, Understanding the brain's limits in non-Euclidean environments is vital for maintaining psychological stability. Ultimately, the science of non-Euclidean perception reveals a fundamental truth about consciousness. Our sense of reality is built on incredibly fragile geometric assumptions. When those assumptions are broken, our minds pay a steep price. The forbidden shapes are a potent reminder that the universe, mathematically, is far stranger than our evolved brains are equipped to handle. For more incredible facts like this, don't forget to subscribe and turn on notifications.